Hello my dear students, good afternoon, and now we will discuss about the electromagnetic spectrum, Planck quantum theory and photoelectric effect. So electromagnetic spectrum means the arrangement of different types of radiations or all types of radiations in the increasing order of wavelength or decreasing order of frequency. So actually we write from left to right, correct? So in that way we will arrange all the kinds of radiations, all types of radiations, I'll tell you, in increasing order of their wavelength or decreasing order of their frequency, and those we call as electromagnetic spectrum. So electromagnetic spectrum means what's the arrangement of different radiations in the increasing order of wavelength or decreasing order of some frequency. Got it, sir? We have to understand clearly. So the arrangement of different radiations in the increasing order of wavelength or decreasing order of frequency is called electromagnetic spectrum. Okay, electromagnetic radiations are what? What types of electromagnetic radiations we have? Means we have from here. Okay, so first we have cosmic rays. What rays? Cosmic rays, gamma rays, and X-rays. Okay, UV rays, and visible rays. Okay, and infrared, IR, micro, TV, and radio. And everywhere here you have two. And visible means you have rainbow colors. You know what are the V, I, B, G, Y, O, R? Correct? 1, 2, 3, 4, 5, 6, and 7 you have, right? We have 7 colors you have. Rainbow colors: violet, indigo, blue, green, yellow, orange, red. Okay, so visible radiation. Here visible radiation is very important for us, and it ranges from 400 wavelength, it's lambda, from 400 nanometers to 750 nanometers. Actually increasing order of wavelength. So lambda increases in this way, and frequency from here to here, and frequency decreases. Frequency what happened? Decreases. And who is the highest frequency? Means cosmic rays. Cosmic rays, gamma rays, X-rays, UV, visible, infrared, micro, TV, radio. Okay, infrared actually 3. One is near IR, near infrared, and middle infrared, and far infrared. Far infrared. 3 types you have actually. Near infrared, middle infrared, far infrared you have. And radio also 2 categories you have. You know this AM, FM. FM radios you know, no? AM, FM. Okay, AM, FM radios. Okay, in this way you have, sir, electromagnetic radiation we arranged in the increasing order of wavelength and decreasing order of frequency. Because you know this frequency nu is equals to C by lambda. So that is nu is inversely proportional to lambda. So cosmic rays has highest frequency and lowest wavelength. But radio is ulta. Radio waves what, sir? Frequency less and wavelength is more, like that. Okay. So this is about electromagnetic radiation. And electromagnetic radiation, you have different radiations: UV radiation, visible, infrared, micro, TV, radio, like that. Got it, sir? So now one by one we will discuss. Here one more thing we will discuss, that is black body of radiation. Okay, What is black body of radiation means? The body which absorb and emits all kinds of radiation is called black body of radiation. What is black body of radiation? The body means what here? The particular thing what we consider. Okay, so that must absorb. Body means here things will come like a halo sphere which coated inside with platinum. Halo sphere which coated inside with platinum act as a black body. Okay, act as black body. Actually in nature there is no black body. Means originally nobody will absorb all kinds of radiation. Suppose our skin is there, we cannot take UV radiation directly. We need some ozone layer. Correct or not? So we are not a black body. Black body means not black color body. So black color body means you are the example, don't select it. Black body in the sense which absorb and emit all kinds of radiations. Getting what I am saying? So black body is existing in nature means no. But we can artificially we can prepare. Naturally no body is black body. Means no one can absorb and emit all kind of radiations. Okay, don't talk about sources or sun. Don't say about source. Who are taking? Okay, who are taking? I'm talking about those. Okay, so can we take UV radiation? Then can we take X-rays directly? No. Gamma rays, cosmic rays. Cosmic rays, if we have cosmic rays, unfortunately fall on one particular building in it, at least that will collapse on us, means we will completely become powder. Okay, like that much highly frequent radiations are cosmic rays. So got it? What is black body? The body which absorb and emit all kinds of radiations is called black body. Who can act as a black body? Very few. I'll give you examples also later on. Okay, so one example I was given for black body, the halo sphere which is coated inside with the platinum. Halo sphere is one sphere which has small hole, and inside you must coat with the platinum. That act as what? Black body of radiation. That black body of radiation was explained by Planck. We call that Planck's quantum theory. What is that? Planck quantum theory. So this Planck quantum theory was clearly explained the nature of black body. So how a particular body absorb or emit the radiation, he was explained. So what actually Planck said? Any kind of black body can absorb or emit the radiation in the form of small packets or quantas. In the form of what, sir? Small packets or quantas, he said. Who said like that? Mr. Planck. So what Planck said means any type of body, any type of black body absorb or emit the radiation in the form of small packets, small what, sir? Packets, or for quantas or quantums or photons. Okay, so any type of a body, any type of a black body, suppose how a body absorb or emit when you oscillate a body. I told you in previous, hesitate the body in presence of certain electric field like that. They'll eject electron, they'll eject energy. First they will absorb energy and then they will emit energy. First, why they will take energy? To eject electron, because between electron and nucleus there is attractive forces. That attractive forces must overcome or not? First absorb. So that absorbed energy in what form? in this packets or quantas or quantums or photons form. Afterwards, that ejected electron has some kinetic energy. That energy in what form? Same form. So any type of black body absorb or emit the radiation emit energy, you can say, in the form of small packets or quantums or photons. Okay, so one photon is equal to 1 h nu actually. In energy actually, this absorbed and emit what? Radiation in the form of some energy actually. So one photon, 1 h nu. Two photons, I was given also some numericals. Two photons means 2 h nu. Three photons means 3 h nu, like this. So here they means Planck was given. Therefore, energy absorbed or emitted is directly proportional to frequency. Then E is equals to h nu. This is energy of how many photons I told you? This is energy of one photon itself. One photon. Energy of two photons. Suppose energy of two photons. Okay, so that is E is equals to 2 into h nu. Energy of 1 mole of photons. Energy of 1 mole of photons. That also I was given in previous. E is equals to 6.023 into 10 power 23 into h nu. Am I given this? Yes, Avogadro number I was given, right? For 1 mole energy. So, absorbed energy or emitted energy is always integral multiple of h nu. Is always what, sir? Integral multiple of h nu. What is the meaning of integral multiple? H nu, 2h nu, 3h nu, 4h nu, like that. So, energy always in the form of h nu or else 2h nu or 3h nu and so on. N h nu, n into h nu, like this. N means some number of photons. 10 photons, 10 h nu, like that. Avogadro number of photons, this n will become Avogadro number. N value how much for Avogadro number? 6.023 into 10 power 23. For solving numericals, 6 into 10 power 23 we can take. So this is about the Planck quantum theory. Is nothing. We discussed about energy already. E is equals to h nu. So what the points here we have to discuss? Energy absorb or emit in the form of small packets, quantums, like that. Energy is always integral multiple of h nu. Black body will absorb all kinds of radiation. Okay, and black body absorb or emit the radiation in the form of photons. One photon means 1 h nu, two photons means 2 h nu, three photons means 3 h nu, like that. And n photons means n h nu. Formula I was given here. And h value I was given already. I have no need to write, I think so. H value 6.625 into 10 power minus 34 joules second, and h value is 6.625 into 10 power minus 27 ergs. This I was given. 1 joule is how many ergs I was given? 10 power 7 ergs, and 1 joule is 1 electron volt, 1 EV is how many joules? 1.602 into 10 power minus 19 joules I was given. Given this one, 1 electron volt is 1.602 into 10 power minus 19 joules, and 1 calorie is equals to 4.2 joules. 18 like that. So 4.2 you can take approximately joules, like that. Kilojoules? Kilojoules, kilocalorie, kilojoules, like that. Getting what I am saying? So this is the way to have a Planck quantum theory. Okay, hope you understood about that. So we will discuss about many types of spectra again afterwards. Absorption spectrum, emission spectrum, hydrogen spectrum, all those things we will understand. And before that you will have this photoelectric effect. What effect, sir? photoelectric effect you will have now. What is the photoelectric effect? The ejection of electron from metal surface. Ejection of electron from metal surface is called photoelectric effect. Ejection means, what is the meaning? Removal of electron from metal surface by using some electric body, external electric field. We will hesitate that metal by using some electric current, external electric source. Okay, so or by sending some rays like that, X-rays like that. So this is the metal surface I was considering. So through this metal surface, I send some X-rays like this, or I get some external electric field like this. Then what happened? This metal surface, I can use any external source like radiation I can send, or else I can use some external electric field like that. Okay, so when you are sending these X-rays, when you are hesitating this metal surface, this is a metal surface. You know, ideal metal surface for photoelectric effect, potassium and rubidium and cesium can be used. Alkali metals. Do you know, not alkali metals, all like so lithium, sodium cannot be, because they are soft. They must have some potential to take that radiation or energy, no? So that's why. So alkali metals, but not all. Potassium, rubidium, cesium. So what happens? So here, when this X-ray sent through this metal surface, what happened? So first of all, here you have a nucleus, suppose, and here outer surface. Here you have electron. Actually, between these two, you have some interactions, attractions. Those attractions, by overcoming, electron must come out like this. Getting what I'm saying? So here two things actually. So here you have, and here to here, and you have to overcome like that. So simply you can write, when X-rays sent through a metal surface. So here we are using what? Metal surface. Through a metal surface you are sending some X-rays like this. So it's taking, and from this electron is ejecting actually. So better put. So here is a nucleus, and here this point to point we have to understand here. So you send some energy, radiation you sent in the form of Hν. What is this? Energy of radiation, E. Some radiation you sent means you given some current, or you given some energy to eject the electron. So it was absorbed first. What is the absorbed energy by metal? Means Hν. After after absorbing energy with some energy, that electron will eject. So that energy what we sent utilized for two purposes. One is to overcome the attractive forces between these two, that is work done, W, work done, or threshold energy, that is called. Sir, understanding? So suppose here I given 5 calories energy. So 3 calories energy utilized to overcome the attractive forces. With the remaining 2 calories, electron came out. Electron ejected with some kinetic energy Ke. Sir, understood what I said? You sent some radiation, X-rays like that, which has some energy Hν, and Hν or 2Hν or, they will say in numerical, not worry. Okay, 1 photon energy sent like that. Energy was given like that. Okay, energy 5 calories energy was sent. Okay, 3 calories energy was utilized to overcome the attractive forces between nucleus and outermost electron. And remaining is what? Kinetic energy remaining. So electron is ejecting. Who is coming out like this? Electron. And outer surface, who is there? Electron is there. So between this electron and nucleus there is some attractive forces. And by overcoming these attractive forces, electron will eject. Sir, once again, last and final, I am giving clarity. You are sending some energy. Electron will overcome the attractive forces from nucleus by using the energy W. What is the W is called? Threshold energy. With the remaining energy, electron will eject. So what you can write here with the remaining energy means what that energy? Kinetic energy, because first you are sending energy. Between nucleus and outermost electron there are attractive forces. Those attractive forces will overcome. For overcoming the attractive forces using some energy E, energy W. W means that is threshold energy. And with the remaining energy, electron will ejecting out. Means that is having some velocity and that's moving away from the surface with some kinetic energy. Kinetic energy means you know everybody, half mv square. So after ejection, that electron has that velocity. Got it what I said here? So what you can say in mathematical formula for photoelectric effect, E is equals to W plus Ke. E is equals to what, sir? W plus Ke. What is E? E is the energy what supplied, energy absorbed. Okay, energy absorbed by metal. Okay, what is W here? Threshold energy. What is this? Threshold energy. What is Ke? Ke is kinetic energy. Kinetic energy for ejected electron. So because the ejected electron has some freedom, no attractive forces from nucleus, so it has some freedom, so it will run away. So total energy what you send, that divided into two. One energy to overcome the attractive forces and one is kinetic energy. Got it clearly? So what you have here, W means what? Threshold energy. So here also E means here you have h nu, and W means what I told you, threshold energy. This is h nu naught. W, that is also energy, na? Energy to overcome the attractive forces. That is also form of h nu itself, but h nu naught we use. What is nu naught? Nu naught means threshold frequency. What is that? Threshold frequency. What is threshold energy definition and threshold frequency definition? Please give me, sir. Means I will give you now. Threshold energy means the amount of energy. The amount of energy required to overcome attractive forces from nucleus. What is threshold energy definition you have now? What is threshold energy? The amount of energy required to overcome the attractive forces from nucleus. Got it, sir, clearly? So what here threshold energy we have? The amount of energy required to overcome the attractive forces from nucleus. And one more important thing is what is threshold frequency means? Same definition here you write. Instead of energy, frequency use in definition. That is threshold frequency. Important for PU also. What is threshold? Define threshold frequency like that they'll ask you. In numericals also they'll ask you. Calculate threshold frequency they'll ask you. Means first of all you must know what is threshold energy. So that threshold energy once you calculated, threshold frequency you can calculate. Because H you know already. H is Planck constant value you know na? So it's very simple to calculate right now. Sir, understanding? Mathematical relation you remember, it's enough. More than enough for us. So E is equals to W plus K. So E is equals to H nu and W is H nu. What is threshold frequency now? What is threshold frequency? The amount of energy instead frequency required to overcome attractive forces. Forces from where? From nucleus. That's it. So what is the final formula? You can write this from this. What you can write? E instead h nu you can write. W instead h nu naught you can write, plus half mv square. Anything they can ask in numericals. Numericals are very important. So they can ask new frequency required to send through metal. Okay, or threshold frequency they can ask, or else kinetic energy they can ask, or else velocity they can ask by using this formula. Substitution, that's it. If you know this formula, you can substitute. What is h nu? Energy radiation, what is sent. This h nu not completely work done, or else threshold energy. In threshold energy, what is nu naught? Threshold frequency. Half mv square kinetic energy. Understanding? Last and final. I repeat, you are sending some radiation, not only in this manner by giving electrode, means anode and cathode like that, but simply one way. Remember, you are sending some radiation. This metal surface absorbs some radiation because you are hesitating, so that some amount of energy utilized to overcome the attractive forces. With the remaining energy, electron will eject. The remaining energy, what we call kinetic energy. Understanding? Means after overcoming the attractive forces, the remaining energy is called kinetic energy, which is present for that moving electron. Okay, understanding? Moving electron have what? Some kinetic energy. Got it? So this is about photoelectric effect. H nu is equals to h nu naught plus half mv square. So remember final formula. So this is total energy what we send. This is threshold energy. What is threshold energy? Definition you have here. The amount of energy required to overcome the attractive forces from nucleus. And threshold energy is also called work function. Okay. So work function, if they ask in exam, don't worry. So this is work function. Okay, work done. All are same. Suppose if they are asking in numerical, calculate work done. Oh my god, work done in this photoelectric effect where given. So threshold energy, I know that threshold energy only called work function. Remembering? So please note all these things, have a screenshot and write down. These are very important for us. So you will have numericals also based on this. In our next class, we will do all those things. Okay, sir? Thank you. And from here, the classes are very important. Next, hydrogen spectrum. Okay.